Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is lesson 3-7 for my algebra class, percent of change. You're going to want to have a calculator available, so if you don't have one right with you, either right now or right after we do the definitions, go ahead and grab one so you have it handy. I think it's going to be helpful to actually work through the problems rather than just watch, but it is, of course, your choice. Our objectives here are to find percent of change and find percent error. Okay, so we do have, as you see, several definitions that we want to go to. Percent of change is the ratio of the amount of change divided by the original amount. And generally that's going to be expressed as a percent, hence they call it percent of change. Okay. A percent of increase is the percent of change found when the original amount increases. Okay, so if something increases, that's going to be, from its original level, it's going to be a percent of increase. Similarly, a percent of decrease is the percent of change found when the original amount decreases. All right. Now, when we get into measurement, we also talk about some percentages, and that's included in that computation is going to be the greatest possible error. The greatest possible error in a measurement is 1/2 of the measuring unit for any measurement. Okay, so a quick example of that might be if you're measuring something in centimeters. The greatest possible error there would be 1/2 a centimeter because the measuring unit is centimeters, and you would use 1/2 of that. So 0.5 centimeters would be the greatest possible error in that type of measurement, as an example. The percent error is the ratio of the greatest possible error to the measurement. Okay, that's going to be easier to explain when we're actually working through one there. Okay, all right, so let's look at our examples. It says the price of a skirt decreased from $32.95 to $28.95. Find the percent of decrease. So the first thing we want to do is figure out the amount of change. So we're going to subtract $28.95 from the original amount of $32.95. And for our denominator, we're going to put our original amount, which is $32.95. Okay, when we subtract these two, we get 4. So 4 divided by $32.95 is approximately 0.12 or 12%. So the price of the skirt decreased by about 12%. Okay, so again, it's the amount of the change divided by the original amount. This was a decrease because the price went down. If your original price went up, and it would be a percent of increase. Okay, which is, we'll see here in example number 2, applying a percent of change. Between 1940 and 1980, the federal budget increased from $9.5 billion to $725.3 billion. What was the percent of increase in the federal budget? So once again, we want to find the amount of the change. So we're going to subtract 725.3 minus 9.5 and use our original amount of 9.5. Because of the way our numbers are given to us, they're both in billions. I don't need to add in the extra zeros. I can use these decimal numbers and work much more efficiently. Okay, so when you subtract, you're going to get 715.8. And of course, you always want to double check me because I tend to write things incorrectly. Hopefully, I did not do that here. And then divide that by 9.5. So that's about 75.35 as a decimal, or $7,535, so 7,535%. And that's a lot, I know, but again, remember to convert a decimal to a percent. You move your decimal point to 3 places to the right. And of course, you see that it did go up by quite a bit. Okay. You have a couple of quick check questions here. And go ahead and either pause now or continue to follow with, and you can check that later. Okay. Example number 3, finding the greatest possible error. You read the bathroom scale as 122 pounds. What is your greatest possible error? The scale is read to the nearest 1 pound. So the greatest possible error is 1/2 of 1 pound, or 0.5 pounds, either as a decimal or a fraction. I know many of you are going to use the decimal, and that's perfectly fine. A lot of these are going into percents. That's probably going to be a little better. Okay, so it's really simply that simple. Know the unit that you're measuring in. Half of it is going to be your greatest possible error. Now, finding percent error in calculating volume. A small jewelry box measures 7.4 centimeters by 12.2 centimeters by 4.2 centimeters. Find the percent error in calculating its volumes. The measurements are to the nearest 1/10 of a centimeter, so the greatest possible error is half of that, or 0.05 centimeters. Okay, so then we have 3 calculations to do. One as measured, so that's going to be length times width times height. So that's going to be 12.4 times 7.4 times 12.2 times 4.2, or 379.18 cubic centimeters. Okay, maximum value. In this case, what we do is we add the 0.05 greatest possible error to each of the given measurements. Okay, so then the measurements become 7.45, 12.25, and 4.25. Multiply those together and you get 387.87 cubic centimeters. Okay, I bet for minimum value you're going to guess. In this case, we'll subtract 0.05 centimeters from each value. When we do that, we're going to have 7.35 times 12.15 times 4.15. When you multiply that, you get 370.61 cubic centimeters. Okay. Now, to find, this is what we do then. We're going to find the possible error. In other words, what is the difference between the maximum and the measured. So the maximum is 387.87. The measured, is 379.18. You just get those and subtract them. That's 8.69. You do the similar thing for the measured minus the minimum. Okay? When you get that, that's 8.57. Okay? Use the difference that shows the greatest possible error to find the percent error. So 8.69 is greater than 8.57, so that's the one I'll use here. So greatest percent error is going to be the greatest possible error, which is 387.87 minus 379.18, which is 8.69, divided by the measurement of 379.18 or 0.18. Okay, so this is a little redundant. You just did this right up here, so you could substitute in the 8.69 directly into here if you'd like, and not have to write this step again if you don't want. Okay, so we're going to write as a decimal, and it actually gives us quite a long decimal, 0.22917.875. Okay, round and write as a percent. So we're going to move our decimal point 2 places to the right, so that is approximately 2%. Okay, so this one is a little involved, but it has a very straightforward methodology to it. It is just a little involved. Okay, I would like you to complete quick check number 3 and quick check number 4, which is on the back, so don't forget to turn the page. Have these ready for the next time we meet together in class, and I look forward to seeing you then. Thank you.